we're gonna use optuna to optimize hyperparameters. Here I load this data frame, and this part is to divide the data set in a same way like the already defined training set, because okay, let me show you in this Excel file. We have been using okay we've been using the second tab, which has the entire data set, and here it's the same data set but with the data set already divided into training and test set. So this cell takes data from the set divided in this tab. Data is divided into training and test set. So I read training part and test part by skipping first line and the last 27 lines, and by skipping 72 lines above. So I take the train part in the Excel file and the test file, test part. So you see, I printed it and it says training is 66, test set is 22. And then I do merge on ID biosite. So ID biosite is this. You see, here it has an ID biosite and it has ID biosite. Both has column name called ID biosite. So when I use merge, I have a data frame, entire data frame from the second tab, which is tab number 1, since index starting from 0, which is 88. Now I have train and test, which is 66 and it has 22. So what I want to do is I want to take this and merge them. By doing that, I'm using this column. So if these values are the same, then they should be the same data. So combine them together. That's what the merge does. So I'm using merge to select from here. I want to select I only want to select from entire dataset. I'm trying to select these compounds included in the training set alone. So that's what merge for. So I did it twice. So from the data frame, I merge it to data frame train, so that among here, only overlapping items will be merged, and this will be the same on here too. So I try to have the same training and test set, because and at the end of this series of video, what I want to do is I want to use same training and test set for model development, and then compare it with author's model. So we are using data set from the research article, and they also developed the model. So at the end of it, we will compare the performance of the model. That's the main intention. And in order to fair comparison of the performance, training and test should be the same. So I use merge to have the same data set. So this is the result. I merged the data frame. So you see, I merge this to this data frame. So you see, overlapped columns appeared once, but other columns are put together. So this part is this data frame, but the other part is from here. So these two data frames are merged together. And then I select descriptors to define X train and test and Y train and test. So this is the main part of the optuna. Here I take the code and adapt it a little bit. And first adaptation is this regressor, because our task is regression. We are trying to predict LC50 value, so it's a regression model, and we need a random forest regressor, not the classifier. So in the optuna tutorial code, it was a classification, but our task is regression. So first adaptation should be the model. You need to use model appropriate for your task. And I decide to run the test with these three parameters. So I define the model with this and use cross validation mean value. So I took most of the part similar. I didn't define dataset inside the function because I already defined this part at the top. And you see the direction is maximized because it returns score of the model, which is basically R squared, uh, basically R square value, which is good if it's high and it's bad if it's low. R square is calculated 1 minus sum of prediction and observation, squared difference between them, then and then observation minus mean value of observation. So its basis is the difference between mean value and the other um, endpoint values. And if prediction is very low, prediction error is very low, so that the difference between them are very small, then this entire part with it will be similar to 0. So that's why R squared is getting higher, closer to 1. If error is greater, then it's closer to, if error is high, then it's closer to 1. So it's going down. So that's why R squared works in this way. And so we want to maximize R square of the cross validation. So that's why direction is maximize, and I put this function here for the optimize, and then specify the number of iteration. Then you will see the result below. See, so it started test trial 0 was 0.36, and the prompt value was this 18. Okay, So n estimator was 18, max depth was 80, mean sample split is 5. So this is a return. And it goes on and on until it's done. And when it's done, I try to check the best result. So it's coming from here. So I get the best result, and this was the best parameter. By the way, I use random forest. Random forest is the model. So you may know this sort of model. Keep dividing into the lower. It's called decision tree. So I have a data set, and each node has a criteria. So data is split into two parts continually and ended up to the last node of the tree, which is called a leaf. So this is decision tree. A random forest is a model with lots and lots of decision tree. So there are many trees, that's why it's called forest. And random forest have many different decision tree models, and use all the different predictions from each decision tree. So these are the prediction results, and voting this result to make a prediction. So here, number of estimator is the number of trees used in the random forest, and maximum depth is the depth of the tree, and mean sample split is the minimum number of samples for the split. So these are the meaning of each parameter. So to define this function, you need to study this model and what parameters are needed, and then you decide which parameter should be tested, and then define them to be tested in the optuna, and then optuna will put the different values in the parameter and then give a result based on the experimentation. I found these set of hyperparameters are the best. That's the result from this optuna. So it's efficient way of optimizing hyperparameters.